Good. Perfect.
All right. So here, although this one doesn't look like a product of a function of x and a function of y, if you recall that addition of the exponents can be written as product of these two, then it is again a separable equation. We call such equations separable because you can separate the x and y's. Okay? Often, people would also say, since this is dx, just move the dx on this side also. The same thing. At the end of the day, you will be multiplying by integrating by dx, so you're going to have dy, right? But sometimes people will say it in that way. All right, so this is gone. If I integrate e to the x, I get e to the x plus c. And this one, to integrate, you have to integrate e to the negative 2y dy, right? So that requires some anti-chain rule, or ideally you have to do u substitution, but that takes too much time. I'll just do antiderivative of e to the x is e to the x. So that doesn't change. But the reciprocal of this negative 2 should appear in front. And then just do a quick check why this is the antiderivative of this one. Just try to differentiate this. When you differentiate this using the chain rule, what happens? This negative 2y is the inside function that comes down, and you have to differentiate the inside function, which creates negative 2. Negative 2 times negative 1/2 does give you 1, so you're back to here, right? So indeed, you can check that this is the antiderivative of this function. And then, now you have to solve for y. Multiply by negative 2. And then take the ln both sides. Because ln and e cancels. These two can't cancel because of these. So you're stuck with this horrible formula. And then finally you divide by negative 2. So you get negative 1 over 2 ln negative 2 e to the x minus 2c. Okay. However, we're not done yet because we didn't take this into account, the initial condition. Okay? Such a condition is called an initial condition. Y of 0 is equal to 1. So look at it this way. Here's an arbitrary free parameter. Whether this is 1 or 2 or 3 or whatever, the function in its entirety will satisfy the given differential equation, right? But if you plug in 0 to get y of 0, so what is y of 0 according to this? Y of 0 is, you're plugging in 0 here, right? You can't expect this to equal to 1 for any arbitrary c. In fact, this should equal to 1 only for one specific value of c. Isn't that right? So you solve this for, to make it equal to 1, you have to solve this for c. Okay? All right. Let's erase this part and continue. So 1 is equal to negative 1/2 ln negative 2. E to the 0 is what? Anything to the 0th power is? 1. I can multiply by negative 2, so I get negative 2 equals to ln negative 2 minus 2c. And then to get rid of this ln, I have to raise it to the power of v. And then add the negative 2 this side, so you get 2 plus 2 plus e to the negative 2 equals to negative 2c. And therefore, I kind of see that this much negative 2c is same as 2 plus e to the negative 2. I can proceed to solve for c and then plug in, but that's not necessary because I mean this is c is just some number, and my goal is to make this entire thing equal to that one. So you can just replace this circle part with that, and that's the final answer. I guess that's a little confusing. Well, let's just solve it and then plug it. Divide by negative 2, so it's negative 1 minus 1/2 e to the negative 2, right? And then you replace now you replace c by that, and that's your final answer. Y is negative 1/2 ln negative 2 e to the x minus 2 times 1 minus 1/2 e to the negative 2. That's your final answer, or you can simplify further by multiplying this. And if you multiply negative 2 inside, then it's going to be same thing as what I just suggested, just replacing this circle part by 2 plus e. Oh, there's a minus here, I forgot. Okay. So negative 2 e to the x plus 2 plus e to the negative 2. That's your final answer. Okay? That's going to satisfy not just the differential equation, but also the initial condition.